So yesterday we have little bit about different constraints, what is supported in a traditional warehouse and what is not supported in the Delta Lake. Today, the context that I gave for that is because if you see traditionally how the evolution happened, initially people were using the file systems for storing the data. Okay. So slowly and gradually, okay. So what they wanted, so to share the file system again and again, it would be difficult and all those stuff. So they started using the database, a server which can hold the data, a server which can hold the data. Okay. So now in the database, we used to create tables and columns. So with this, it was not sufficient. So having a table and column, let's say you are doing a shopping in a Amazon website. Let's understand how many columns you are going to fill. Okay, let's say you're a customer. Okay, you'll have a customer ID, name, phone number, address, okay, phone number, address, okay, and then what are the items you are going to buy, okay, item type, who is supplying that item, okay, how many items you want to buy, okay, number of items you want to buy, cost of each item, total cost, okay, delivery address, okay, whatever you have. So it goes on. The list goes on to a biggest possible extent possible, like maybe probably 100 columns. Okay. So when I'm trying to insert something, trying to insert something, okay, for all of these 100 columns, then it will be then it will be very difficult. It will be very difficult. Means it is not difficult, it will be time consuming. Okay, I am trying to, okay, if you try to select, if you have a DBMS, try to select one column, select column one. You can do one also if you are using SQL from table, okay, or you can do select star from. You can observe the difference, okay, you can observe the difference, okay. Doing select one will be faster, select star will take a lot of like that inserting, okay, few columns. So probably people came up with this idea. Probably let's say I will store the customer details in one table, customer ID, customer name, customer address, phone number, all those stuff in one table, and then keep transaction info like and again item information, item information in another table, item type, item name, okay. So cost of the item, okay. So, and where all it is available, where all it is available, and the quantity that is available. So, like this transaction table. In the transaction table, this will have reference to customer ID, only customer ID, okay, item, okay, and then the quantity. Then it comes to the cost. So, instead of inserting hundreds of columns every damn time, okay. Now I'm going to just insert customer ID, item details, customer details, like one identifier which can identify the whole row in the customer. Customer ID will identify the whole row in the customer table. Item ID will identify the okay whole row in the item table. And then you are going to take the cost and the quantity. So this is where people came up with the referential integrity concept. People came up with the referential integrity. integrity. So that is the foreign key. That is the foreign. That is the foreign. So this is whenever you are doing whenever you are going for a OLTP system, it is normalized. It is normalized. Normalization, why we do? To avoid redundancy. Because otherwise you are going to store, if you use only one table, you are going to store customer ID, customer name, item type, item name, item related information in only one table. One every row you are going to repeat the information, which is not required. Which is not required. Okay. That is to avoid redundancies. To avoid redundancies and also to support okay quick insert, quick insert and update. So that's when they introduced from DBMS, they introduced RDBMS, RDBMS, okay, Relational Database Management System. Okay, the one that we are doing right now, okay, is OLAP system. OLAP system, okay. So traditionally, SQL Server, if you have, okay, it can be used normalized table in a SQL Server. Normalized table will be used for OLTP. Okay, normalized means you are going to split the tables to the biggest extent possible to avoid redundancy and to make insert and update faster. Okay, now in the same SQL Server, okay, you can create denormalized tables. Now I want to do reporting. Okay, now I want to do reporting. Okay, so if you see traditionally the customer related information can be stored in few tables, not one table. Okay, so if I want all the customer information, I need to join all the customer related tables. Can I put it in one table? Put it in one table to avoid more joins. Because whenever a reporting guy is doing, whenever a reporting guy is trying to do, he needs to read the data faster, read the data faster. So we need to do the denormalization. Denormalization. Okay. OLAP is all about denormalization. OLTP is about normalization. Okay. This is how it started. This is how it started. So anybody got any doubt in the simple concept that I explained? Please ask. I will continue explaining about the data warehousing concepts, but you need to know what is normalization. People are still asking in the interviews because my previous batch students they started attending after 50-60% of the course is completed. They started attending interviews. They are still asking normalization and denormalization. Some of you may not know, so I have to teach. That's why I'm covering. Anybody not able to understand, please ask. Okay. So in the data warehousing concepts, basically, as I told you, OLAP, OLTP is a conceptual kind of doing the things, conceptual kind of doing the things. Still, people uses traditional SQL for OLTP. Don't assume that we'll use big data systems for OLTP. No, that is not the case. Okay. OLTP is still with the database. So OLTP is still with the traditional data warehouse databases. It's traditional databases. Okay. So we have to think that it is going to stay forever. It's going to stay forever. So normalization basically, as I told you, one particular table you are going to split. Okay, you are going to split into small chunks so that the transaction insert and update will be super fast. Okay. Denormalization, and again you merge all these tables if possible and then put it into one table. Okay, if possible. It is not that you must be doing all that. Okay. So when it comes to normalization, we have three types of normalization. One, first normal form, second normal form, and third normal form. Okay. First normal form, second normal form, third normal form. Each of them, okay, each of them you are going to split. So each of them having a different priorities actually. Whenever we talk about first normal form, whenever we talk about first normal form, okay. So in the first normal form, let's say there is a name. Let's say there is a name. Can I split the name to the smallest extent possible? Can I split the name? Let's say whenever, okay, girls get married, okay, they they become like they will change their surnames. They will change their surnames. Nowadays it is not the case, but yeah, traditionally if you look at Indian marriages, okay, they will have their surname and again they will tag the surnames. Let's say if you take Aishwarya Rai, Aishwarya Rai Bachchan, Okay, Rai was her surname, but again she added Bachchan. So name can be split into F name, middle name, last name. Okay, and also initials. If somebody use initials, they will use initials also. So whenever you apply a first normal form on a table, you are going to just split it into lowest atomic level possible, which cannot be further divided. Which cannot be further divided. Let's say address. Address can be done into, if you see now, address are given address line 1, line 2, street number, landmark, okay, and then you have a pin code. So lot of things comes into picture even there. So you are going to split a column to a smallest atomic thing possible. Atomic means you cannot divide it further. You cannot divide it further. That's the first normal. Anybody got any question? Okay. So when it comes to second normal form, hello.
Yeah, how many sessions you are teach to complete this course
So have you attended first session or you are asking right now?
right now?
This is the first class.
Yeah,
What's your name?
yeah, Vicky.
Okay. So I'm taking around 35 to 36 classes.
So in this entire all the modules are completed or only
All the models will be covered. Only topic if I'm teaching, please ask the questions related to topic right there. Other questions you should be asked in the end. Okay, let's not bring non-related topics right now. Any question, anytime is not entertained. In the end, you can
yeah
ask.
now yeah
Yeah.
now I'm asking about topic related. So
Hmm.
where we can use these normal forms? How we can use? Please provide some examples regarding the SQL side.
I have already told it is for OLTP systems.
No, just I'm asking not a definition. I'm asking about the real time, like how we can write queries,
See, you
where
know
we
what
can
is
write.
OLTP? OLTP, I have
Yeah,
already told what is OLTP. Okay.
yeah, that is a
If you don't
transaction
understand
processing data.
OLTP, if you don't understand OLTP, that's a different story. I keep explaining since the day one what is OLTP, what is OLAP.
Yeah, I know the difference. I know the basic
Mhm.
understanding, but where we
Hmm.
can use these normal forms?
That
Actually,
is
it is
for
only
OLTP
definition
system.
purpose.
See, do you understand what is OLTP first of all? Or you are
Yeah,
just
it is an
arguing
online
with me,
transaction
right?
processing.
Yes. See, whenever you tell OLTP, let's say you are doing any application in any organization, while creating a tables for this application, let's say you are going to use, let's say, a website, okay, online shopping website, okay. If you have tables connected to this website, those tables will apply this normal, okay. You understood now?
Yeah, okay, but definition, okay, but what about real, where we can use? Mention the query or
Do
anything.
you understand what I'm trying to
That's,
say now? In the application, whenever you are doing any application, e-commerce website, let's say Amazon, okay, you are trying to do shopping. The tables in the back side, okay, that will be normalized. That's what I'm trying to say. What else example you want?
okay, yeah,
Data warehousing concepts, because I'm not covering any RDBMS discourse. Data warehousing concepts is important for clearing the interviews. That's why I'm covering. Anyhow. So when it comes to second normal form, okay. So the rule of the second normal form is you should have some primary key defined in a particular table. First normal form, is to split the columns to lowest extent, like split the columns to atomic level possible. Second normal form is to create a primary key in a table. In a, okay. So when you create a primary key, this one particular column will identify the whole row. Will identify the whole row. Okay. So that means, let's say if you have, let's say, a table with a student. In a student table, you will have a student ID. Okay, student ID, normally what people will do, they will create a identity column, identity 1 comma 1. Okay, when you say identity 1 comma 1, whenever you try to insert other information related to student, let's say student ID, student name, okay, student, let's say branch, all the information related to student, when you are trying to insert, you don't insert a student ID, it will be inserted by itself. It will be inserted by itself, like 1, 2, 3, 4, like that. Whenever you are inserting any new row, it will go on increment the values and then it will insert the data. It will go on increment the values and then insert the data. That's so whenever you create a second normal form, that means they need a ID, okay, which can identify the whole row, which can identify the whole. Okay, in the simplest terms, instead of reading whatever is given in the simplest terms, that is what you are going to do. Now, whenever you are applying third normal form, so if at all if you apply second normal form, you need to apply first normal form and apply second normal form and then apply the third normal form. Every normal form you should follow in the order rather than going just to the third normal form or a second normal form directly, rather than implementing the first normal form. So when it is a third normal form, okay, when it is a third normal form, okay, let's say I have a student, okay, I have a subject, then you are going to create a class with the IDs of the students in the class. So as I told you, whenever there is a customer, there is a customer ID and all the customer related information, items, okay, in the items you have item ID, item name, and all the item related information. When you go to a transaction table, here you are going to have transaction ID. Along with the transaction ID, there will be a customer ID and item ID. Okay? Then you will have the transaction information like quantity, amount. This information you are going to have in the transaction table. So here, in the case of third normal form, it is you need to create a table, okay, kind of a bridge table rather than having a transitive dependency. Okay, students and the subjects, you need to create a class. Okay, so you need to have a bridge table which don't have a which so here this table student will have a transitive dependency on the subject. Okay, transitive dependency on the subject. So here this should be done in such a way that you should not have any subject information in the student table, so that you will have another table. If you have a subject information in the student table, then let's say Vinod is going to college, he will study different subjects. So we know the information will be repeated 6 times, which is wrong. So we need to have separate table for the subject, and you need to have a bridge table, okay, which will have name information and then the subject information. That's the transaction table that I explained in the beginning. That I explained in the beginning. So whenever you're applying the normal forms, we have first, second, and third normal form. These are the important normal form. We have basic code normal form. We have fourth normal form and fifth normal form. That is applied. That is applied in a critical scenarios. Okay, we don't normally use it in a daily basis. Okay, so that is also there. If at all, if you want to know, you can try to know. Okay, basically, whenever we talk about normalization, we talk about all these systems. We talk about all this system. Now, whenever we do a data warehousing project, we'll have different layers. One is staging, another one is ODS layer, another one is the data. Okay. So what is a staging layer? Okay. What is a ODS layer? So they will ask you, can you please explain about your project, how you have designed the project? Okay. If you say I have traditional warehouse experience. Okay. Now what is staging? So whenever in the source system, let's say there are 100 tables. I want to bring in all the 100 tables. Okay. So in the staging layer, you are going to create a replica of the table. You are going to create a replica of the table. Okay. If you create a replica means I have a table with 5 columns in OLTP system. OLTP means you are going to use it for doing any kind of online transaction. You are going to book an appointment. You are going to buy something online. You are going to, let's say, study, let's say, even Udemy. These kinds are like OLTP systems. Okay. You are going to generate the transaction information continuously. Okay, you are buying something, you are doing a bank transaction, all these are OLTP systems. Okay, let's say in a particular table there are 5 columns. In staging area, you are going to create a same table having 5 columns. Okay, and you are going to extract the data on a daily basis, okay, and you will do a truncate and load, truncate and load. That is what you are going to do in the stage. That is what you are going to do in the stage. Okay. When it comes to ODS, so whenever we say staging ODS and the data mart, it's a logical separation of the tables. Logical separation of the tables in the database. Okay. I have different databases. In one database, I will just do, okay, I will have a source table, exact similar source table. I will do a truncate and load. In the second database, I will maintain the historical data, historical data of the source table. I'll maintain historical data of the source table. Okay. Let's say I have a table customer over here. Okay. I will just do truncate and load every time. Here I'm going to maintain whole history of the table. When it comes to data mart, when it comes to data mart. So from here to here, you are going to daily do a insert and update. Insert and when it comes to data mart, you are going to design a dimension, dimensional model. You're going to design a dimensional model. Okay. So you talk about dimensional model, whenever you talk about dimensional model, you will have facts and dimensions. Okay, what is a fact? What is a dimension? Let's say I bought something. Let's say I bought something in a particular website. I bought something. Okay, let's say I bought, let's say I log into Amazon. I bought 5 iPhones. Okay, I bought 3 iPods. Okay, I bought 3 earpods, whatever. Okay. Now, let's say this 5 iPhones, 3 earpods, okay, and 3 iPods. What is the like the quantity we know now? Okay, the quantity we know, and then the amount that I pay. Now, here if you could see, there are a lot of ways that we can analyze this information. There are a lot of ways that we can analyze this information based on few things. Okay, what are those few things? Okay, let's say I am trying to buy some product. I'm trying to buy some product. Now, here the product can be like iPhone, iPad, or ear. Okay, type, product name. Okay. Now I'm trying to buy iPhone on a particular date. Okay, on a particular date of purchase. Let's say. Now I'm trying to buy, okay, let's say product. I have product, I have date, customer who bought this particular information, who bought this particular product. Okay. Now I have product, I have date, I have customer. Okay. Who is the, okay, manufacturer? You don't need this information, but companies would need this information. You don't need this information as a, basically this would be helpful for them who is supplying this particular. Okay. Now you are going to do the delivery of this particular product. Who is going to do the delivery? Delivery thing. So if you see, if you can analyze the, okay, analyze, slice the amount information using on a particular date, what is the total amount that is generated, who is the customer, how many products he bought, okay, a product of particular type, how many products is sold, okay, who is the manufacturer of that particular product, and who is going to deliver this particular product. Okay. So these these tables which are, okay, influencing, okay, these tables which are influencing this amount and then the quantity, okay, amount and then the quantity. So those are the dimension tables. Those are the dimension tables. So if you could see, this amount can vary based on a product. This amount can vary based on a date. This amount can vary based on the customer. This amount can vary based on the manufacturer. Okay, because there cannot be only one customer who is buying. There can be 100 customers who will be buying. Okay, there can be hundreds, thousands of people who will be buying on a particular date. There can be hundreds of iPhones sold. Not only this customer has bought. So this amount can be sliced and diced based on the different okay, different attributes, okay, different things. Those are the dimension. Those are the dimension. Okay. If you look at the amount and then the quantity, those are the, those which can be sliced and diced based on other parameters. That's measures, and measures are normally stored in the fact tables. Measures are stored in the fact tables. Dimension tables, product, date and customer, manufacturer and delivery system, and fact transaction will become the, okay, will become the fact. So traditionally, we'll have fact table, and fact table will have relationships to this dimension tables. Like product ID will be there, date key will be there, customer ID will be there, manufacturer ID, delivery. So this particular fact table will have relationship to all the dimension tables, all the dimension tables. Okay. Now these dimension tables and fact tables are heavily used in the traditional data warehousing, even in the case of bronze, silver, and gold layer. That's a Mendelian architecture. In the case of Databricks, we are going to create facts and dimensions in the final project that we are doing. We are going to create these facts and dimensions. So the basics remains the same. Basics remains the same. We are doing it in a different way. We are doing the data engineering in a different way. Now, there are, in the case of facts and dimensions, okay, there are different types. We have, okay, schema. We have different types of schemas. Okay, that is star schema and snowflake schema. What do I mean by a star schema? What do I mean by a snowflake schema? Okay. Let's say I have one center fact connected to all the dimensions, connected to all the dimensions. Then it is a star schema. Okay. Let's say for a customer, okay, let's say there is a customer. Customer address may tend to change. So I want to split the customer address and store it into a different customer address information. If you look at Amazon cart, I have, like, let's say different addresses. Maybe I will be in office. Sometimes I will ask them to deliver to office. I will be in home. I will ask them to deliver home. I will be in my native. They will ask them to deliver my native. I will have 7 to 8 address types. Okay, you are maintaining customer address in a different table. Customer address, different table. Customer address information. Now, if you look at this fact transaction, it won't have a direct relationship to the customer address. It is having a transitive relationship. I have to go through customer and then to the customer address and then to the customer address. Okay. Here you are maintaining a relationship. You are maintaining a relationship. Okay. Between different dimension tables which don't have a okay direct relationship with fact. Direct relationship with fact. That is the snowflake schema. That is the snowflake schema. Okay. So sometimes let's say the interviewer will ask like which is better, what you are going to use in a real time, which is better. Okay. Depends on the situation you are going to use. It is not one particular. There is no concrete answer that I will use only star schema. If you ask, if you ask any person, if I'm doing select like reading of data, then I would say the performance, whenever it comes to performance, if I have a direct relationship, then I will fetch the data faster. How I will fetch the data faster? I don't need to do multiple joins. If I do multiple joins, then it will become negligibly slow. Negligibly slow. Okay. Now here star schema, snowflake schema, star schema. So if anybody would like to answer, is star schema normalized or denormalized? And snowflake schema, is it normalized or denormalized? If anybody could answer. Normalization means splitting of tables. Denormalization means merging of tables. So is star schema normalized or denormalized?
Denormalized.
Star schema is denormalized. Absolutely correct. Snowflake schema is.
Normalized.
So which will be performance wise, which will be better?
Denormalized table is.
Yes. Performance wise,
Star schema is better.
yes. Performance, better performance. And this is not comparatively less performance. Okay.
Yeah, please
So
repeat what is normalization, denormalization. It means splitting or some. What is that?
normalization means splitting of tables. Normalization is splitting of tables. Denormalization means merging of tables.
Okay.
So interviewer will definitely ask how many types of schemas are available. What are those? Then you say star schema, snowflake schema. Then he immediately asks what is the star schema? Okay, which is performance wise, which is better? Okay, and which is more normalized? So you must know this concept. You must know this concept. Conceptually, it is really important. Okay. Then if you ask me, okay, I have, if you go to this, I have given a RDBMS. I'm not teaching RDBMS. Okay. Sorry if I not conveyed this before. I'm not teaching RDBMS. I'm here to teach Databricks related stuff. But I'm teaching this because it is really, really important for you to understand. Some of you don't have a data warehousing background, and it is for data warehousing background also. You need to have, you need to do the interviews. That's the reason I have to. So here there is something called as a RDBMS score. Okay, there is a zip file called RDBMS score. In that, I have explained all these concepts also. There is a data warehousing concepts, but if you want to practice all this RDBMS related stuff, then you need to go over here and then practice. You need to go over here and then practice. 1 second, yes. Okay, please go through this particular. If at all, if you don't have a data warehousing background, practicing will help. Then you can ask me, how can I practice? Do I need to install SQL? Okay, you can. This is the RDBMS code. You can go and check for this information, whatever I'm teaching right now, which will be helpful for you. Okay, there is online thing called SQL Lite. You can practice over here. SQL Lite online. Okay, if you do, you can practice the SQL free. The online stuff you can just practice. If you want to practice, you can practice online. Sorry, SQLite online. Okay, if you want to do it, it's up to you. If you can install SQL, you can do it and practice. If you do this, you will be perfect in the SQL. You will be perfect in the SQL. Okay, please do it here. It's a free tool. You can create table. You can do any stuff you would like to. You can create. Fine. Any questions? Anybody having, what is a dimension? What is a fact? What is star schema, snowflake schema?
For data integrity, which is good better? Hmm.
So data integrity, we always need a normalized tables. Normalized tables. Okay? That is the, let's say OLTP tables, if you could see, they are more clear. So OLAP for reporting purposes, what we do, we try to merge, mix and merge things. I try to, let's say I'm doing a fact table. I will have some information related to some other fact table also I will store in multiple places. I will store the same information. So when it comes to data integrity, OLTP is more clear, but OLAP also you can manage. OLAP also you can manage. But to improve the performance, sometimes you will try to just keep it in multiple places. Because if I doing reporting, I cannot joining fact to fact will be very, very slow. So you tend to just avoid that joining fact.
Vinod,
Yes, please.
uh, Vinod, in a real-time scenario, so right now what we have explained in terms of Snowflake schema and star schema. So
Yeah,
is this database is already available, right? Do we
no,
do as a data engineer?
I will explain that. So some of you, okay. So Snowflake schema, star schema, what you will do. So let's say how you will, you have to do it as a, there will be a data architect in your organization who will be creating this, who will be creating this. Okay. How we will do? Let's say you take a HR tables. Let's say you have a HR related information in any organization. Okay. Now you will have a source. Let's say you are having a Oracle, or you are using a Salesforce, you are using Microsoft Dynamics, or you are using SAP. They have HR related tables. Okay. They will, okay, they will have hundreds of tables. They will have hundreds of tables. Now, as a data engineer, HR people will come to you and say, I want to do some data analysis. Can you please prepare a data warehouse? Can you please prepare a data warehouse? This is the OLTP system. People cannot tap into OLTP system because OLTP system, if at all if you tap and if you do the reporting, then there will be deadlocks and the application will, it will bring down the application. So you are going to create the data warehouse. So now you will identify, you will quiz the HR what all information you need. Okay. So basically in the HR system, you are going to say what is the headcount of a particular organization for each department wise, for each function wise, division wise. Okay. Now let's say apart from that attendance information, okay, salary information, okay, and interview information, like this you will have different information there. Now once you get this requirement, what you are supposed to do, then you need to sit with the HR analyst. You need to work with HR analyst. Say, I need this, some business analyst will be there. Can you connect this front end related tables, front end related information to back end information? Back end is the tables. Now he will identify the data points. He will identify the data points. Different data points he will identify. Different tables and columns he will identify. Okay. Now what he will do? You will list down the tables. You will list down the tables. Let's say I will take a simple example. Okay. Uh, I'll just check it's for my purpose I created. Okay. This is the HR mapping sheet. Okay. What people will do? Will identify the source tables, and then we need to we need to okay understand all of them, and then create a data model which will help them which will help them okay analyze the data, analyze them, because the tables that are available here will not be easily understandable, will not be in a way that people can directly use. Okay, you need to create some meaningful tables, you need to create some meaningful tables. So in a organization, okay, let's say here, okay, in the Oracle, let's say ORCL, okay, for all people F. Okay. Now I want to know all the information. I want to create a table with all this information. Then what people will do? They will create a dimensional modeling. With the dimensional modeling, you are going to take the source table and then the target table. This is the target table with the dimensions and facts. You are going to create this mapping document. You are going to create this mapping document and how to derive, what to derive, and all this. Okay. Then you are going to do the development. Then you are going to do the development. This is bit straightforward, but normally you will have a lot of transformations that you will do. Okay, so it's all depends on how you want. Like this, you are going to create. Okay, and then if you want to create a data model, you can create a data model. I will show you some simplest data model that I just for example I'm showing. Okay, people will create a data model. Okay, and then you are going to use it. So this is one diagram. It is still opening. Okay, give me 1 second. So this is the data model that is created for one of the use cases. Okay, what is the physical day? Fact project, physical day, expenditure type, task, and then you have project. With this, you are going to derive the cost of all the information by connecting to all these tables, by connecting to all this. This is what your data architect is going to do. This is what I do in a day-to-day basis. Okay, you need to create this. If you see here, everything is directly related to fact. This is the star schema. This is the star schema. Okay, if at all, if it things are not directly related, there are some complex. Look at this. This is not every table is not directly related to fact. Okay, I have still I have to work on this. This is not completely, but if you see, there are a lot of transitive dependencies. This is dependent on this, and this is dependent on this. This is dependent on this directly. That is fine. But if you could see, still lot of improvement needs to be done. It is not final. It is still in like analysis stage. We need to understand this relationship and create the data. This will be done by your data. Done by your data. Here also, if you could see, there are multiple fact tables, and each of them are related to different dimensions. You cannot sometimes there is no way that you can create a direct relationship with this to this. So you have to do that. Just understand this. This is how you're going to do. This is a snowflake schema. This one is a star. Got a direct relationship. When it got transitive, like fact related to dimension, does dimension related to other fact, then it becomes a snowflake. We are going to do this. We have to do this along with the data architect, business analyst. Lot of stakeholders will be involved. Lot of stakeholders.
Understood.
Did I answer
Understood.
your question? Yeah.
Yeah, yeah.
Yeah.
So in this example, we are using Oracle database, right, as an example. So in some
Yeah.
companies, we might use Oracle SQL also, some PostgreSQL or MariaDB. So in those scenarios also, from data warehouse, do we need to integrate with other databases so that we pull the relevant information?
Yes.
Is that
See,
possible?
data. You are going to do that. So
Okay, okay, okay.
if you see traditionally any data ETL tool, okay. If you see SSIS, it does a SQL Server integration services. You are going to do the data integration. That's the basic. Okay. Now every organization, like I have worked in organization where they have 110 systems. I worked for 8 years. There was not a very big team. We have integrated 30 systems. Okay. Those are the mission critical system they want to analyze. You cannot go to 30 different system and do the analysis. So you are going to create a, okay, data warehouse. You are going to create a data warehouse, or you can call it as now we are calling it as a delta lakehouse. That is also fine. It is all about analysis. You are going to do one point, single point, spot, you call it as, okay, single point of truth, single point of truth. Okay, that's the data warehouse, and all the analysis should happen. Only analysis should happen. You are going to do integration, okay, data quality, okay. You are going to do data model. You are going to do ad hoc analysis. Everything should be done. Should not be allowing people to touch the OLTP. OLTP is mission critical. That's the best. This is also important nowadays. Data is everything, but OLTP is where the business runs. So you cannot touch the OLTP.
Thanks, Vinay. Thanks for the clarification. I understood. So one last question on the same topic. So previously you were explaining that HR example, right? So that was the request
Mhm.
you received and you were preparing and everything, right? So
Mhm.
based on HR requirement, you prepared everything for data architecting, data analysis. So once the
Yeah.
task is completed, we still need to maintain. Is there any such policies the company will have it? I'm thinking in terms of the data increase on day-to-day basis. Once the task is completed, will you delete all the stuff, or you archive all the stuff, or how does that work in real time? Or you save all
Data
this
engineer
information
job.
in data?
So
Yeah,
data engineer job. Our job is to create data pipelines. Okay. Data pipeline is to load the data, load the data, load the data every day incrementally. And some of the small tables, you are going to do a full extract. All the transaction related information. Amazon is doing $81,000 business in 1 minute. Okay. You need to do a incremental extract for those tables. The transaction tables of Amazon, you need to do a incremental extract. I'm just giving a hypothetical example. Okay. I was working in a healthcare office. The number of tables available was 20,000 tables, source tables. Now, among these 20,000 tables, I cannot do a full extract every day. You are going to do a incremental extract. How you are going to do incremental extract? I will be showing that while doing the ADF and also the final project. You are going to create a load control table. You will store the table name, okay, extraction type, and also date. Now, table, let's say transaction, cost transaction. Okay, you are going to extract incremental name. Okay, date, which column I need to do that. In the source, you should identify last updated, whatever any column which you can extract it. When it comes to customer table, let's say you have a small customer base, I'll do a full extract, and then you don't need a date. You don't need a date. So, like this, you are going to manage. And it is the job of the data engineer. Any office, you will have a support team who will constantly monitor this pipeline, constantly monitor these pipelines. Pipelines, if there is a failure, they will notify level 1, level 2, level 3 support, and they will fix that. So it is our job. It is our job. Maybe you may not be doing, maybe some others in your team would be doing this stuff. It is our, you need to schedule them. You need to schedule.
Thanks, man.
Any other person, anybody having any doubts? Any- Ah,
We know that previously you said there's some bronze, silver, and gold, right? What is that?
yeah. Okay. So whenever it comes to whenever it comes to Databricks, what this guy have done? I told you we are going to use staging, ODS, and data mart. Staging means truncate and load. ODS means you are going to do merge of staging table to ODS. Data mart, you are going to altogether creating a new tables. New tables. So bronze, silver, and gold is exactly a similar concept. Bronze, it's kind of truncate and load. ODS, you are going to like silver, which is the you are going to maintain the historical information. Okay, gold is the gold standard tables, which is so nowadays what people are doing in the organization, whenever you create these ETLs, people verify whether the data is trustable, whether I can do the reporting or not. So whenever you say the data is in the gold DB, then it is considered as a completely trusted data and people can use it. That's the data mart stuff. In a traditional way, if you speak, it's a data mart stuff. So whenever these guys, Databricks guys, what they have done, they wanted to give a provision saying like you can achieve bronze, silver, and gold in the lake house, okay, by using our infrastructure or a SaaS product. That's why they have given this bronze, silver, and gold. People started using this terminology instead of using staging, ODS, and data. Bronze, silver, or gold is aliases of this. That's it. It's a logical division, of, logical classification or division of data. It is also called as a Mendelian architecture. You can do this. There is a possibility that you can do. That's why they have.
So this terminology will follow in Databricks, bronze, silver, and gold, or
Yeah, it is followed in the lakehouse architectures. So basically in the Databricks. And also Synapse is having the lakehouse. So people are using same terminologies even in the Synapse nodes if you are using Synapse nodes. But basically you may not use, but you need to aware what is. So in my projects, I don't use bronze, silver, and gold. Some projects I use bronze, silver, and gold because that made sense for the customer. Some people used same old terminology, staging, ODS, and data. So, any other questions anybody having in understanding?
So, we know that Databricks is like a ETL tool, or how it will it is a database.
Databricks, in the case of Databricks, is a tool where what they have done, Databricks, they have collaborated with different clouds. Different clouds. Databricks is a software as a service, software SaaS tool. Okay, they have collaborated with the different clouds. Okay, and they are going to use a data lake as a database. Data lake as a database. Okay, and compute also they can borrow from any of the compute also they borrow. Okay, now in the case of Databricks, what he has done is he has created a software. He has created a software where you can do data engineering or a data warehousing stuff easily. Okay, it's a tool where you can do this data engineering, data warehousing stuff. That's the in a not in simple terms. In a simple terms. So when it comes to big data, okay, we have split the things into like compute also we need. Compute means the computer power and the storage. Okay, that he will borrow from cloud providers. The cloud providers because this software exists on Azure, on GCP, on like AWS. So they will get the money for compute and storage. But tool is a UI based tool he has created for us to do the data engineering stuff. It supports creation of databases. It supports creation of code and Excel. You can. It is a very good tool for doing the data science stuff also. Now Google also came up with same big lake, and Microsoft came up with the Fabric. Is equivalent to Databricks, which is equivalent to Databricks. Okay. So there is one more that I wanted to cover is different dimension types actually. So I'll just cover different types of dimensions. Okay. So in a whenever we create a dimension table, let's say a date dimension, a date dimension. Okay. This date dimension can be used in any fact table. It can be used in any fact table. Let's say customer related information. There is a table which stores a customer related information. Customer is very important if at all if you are using a e-commerce website. Okay. So every table, every fact table will have a customer related. Like if you create a data mart for a e-commerce related data, then data and customer related information will be used in every table. So if at all if there is a dimension which we are using in many tables, in many fact tables, then it is a confirmed dimension. It is a confirmed date, customer, like that, like let's say item, okay. Let's say manufacturer. Manufacturer you may not need in every fact table. So that cannot be classified as a confirmed dimension. Okay. So you need to aware of this. What is a confirmed dimension? What is a confirmed dimension? The dimension which you tend to use in multiple fact tables is called the confirmed dimension. Okay. There is another different other types of dimension called role play dimensions. Role play demo. It is a terminology. It is not that you are creating some table as a role play. You call the table just as a confirmation. Role play dimension. Let's say there is a employee table. Okay. In an employee table, a man, let's say CEO is a employee. Okay. CEO is an employee. Okay. But CEO can have an employee ID if since he is a boss, he also called as a manager. He's also called as a manager. So CEO can be an employee, CEO can be a manager, and also CEO there will be lot of other like CIO, CDO, lot of other C-suite people will be reporting, and then there will be VPs, there will be directors, there will be managers, then there will be leads, then there will be the end people who will take everything. So these employees, this employee table will play a different role over here. Will play a different role. Okay. Sometimes it can play as a manager, or it can store manager related information also. It can store, okay. It can store employee related information also. That is the role play dimension. Different roles at different times. Different roles at different times. Whenever, okay, you take date, okay, you will store the date key everywhere. Okay. You have, as a customer, you have a purchase date, there will be a delivery date, okay, and then payment date. So same date, you are going to use different scenarios. That is the role play dimensions. Role play. These are the important dimension types. These are the important dimension types. Okay. Apart from this, we have slowly changing dimensions. Slowly changing dimensions. What do I mean by a slowly changing dimension? Okay. Let's say in your organization, okay, there is an employee, okay, employee ID, okay, his designation. Let's say this employee ID one, his designation is, let's say, software engineer. Tomorrow he get promoted to senior software engineer. Okay. Do I need to maintain history information, history information of the designations? Okay. Do I need to maintain that? If you want to maintain, then it becomes slowly changing. Okay, if you want to maintain, then it is called as a different type. If you don't want to maintain, it's a different type. When if you don't want to maintain any history, I just want to update software engineer to SSC, senior software engineer. Okay, I don't have a history. If anytime I want to see when he was a software engineer, from which state to which state, I don't have it. Okay, this is called as a slowly changing dimension type one. It's for the slowly change. We'll be doing this while learning the SQL practically. This is all conceptual. Okay. So from tomorrow we'll be doing practical. I'll be showing you practically SCD type 1, SCD type 2. If you want to maintain, because these are all concepts, this is practical. So we need to show you practical. If you want to maintain history, EID, okay, EMPID, let's say, if you want to maintain history, what all things it needs to maintain the history? Let's say start date, end date, for really. Okay. You can also maintain current flag. You can also maintain. I will explain the importance of the current flag. Employee ID 1, he was a software engineer from so and so date, like 0101 2021 and 2020, okay, 2000 to 0101 2002. 2000. And what is he doing now? The current flag. Is it a current? Right now, yes. If you insert a new role, let's say same employee, his designation is senior software engineer. Okay. It changed. It is 2002 I have given, then current flag will be 0. Why I have given 0? Because it ended on a particular date. If there is an end date, which is greater than, which is less than or equal to this current rate, which is less than or equal to this current rate, then it is current flag will be zero. Current flag will be zero. Same on this state, he becomes a senior software engineer. Okay, and current rate will be, let's say you can give, normally people will give 0101, okay, 2099. Some future rate, it should be greater than the current rate. It should be greater than the current rate. Or you keep it null, or you keep, it's up to you. Depends on your project. You can give future rate, 2099, and then the current flag. If you go on becoming a CIO, okay, then you go on updating this. This is till 2003, 2004. Update the current flag to zero. You maintain all the history. Okay, I mean, so one, okay, then CIO, then you can say he started becoming CIO in the year 2022. End date is the current values. Like this, you are going to maintain historical history information of a particular column, that is a slowly changing dimension of type 2. Slowly changing dimension of type 2. Okay. There are some companies who are concerned only with the smallest history. I don't want to have a lot of history. SCD type 3. Then they will maintain only, depends on the project. Okay, they will maintain only fewer history, like last two, last three information, not all the 100 designations changed. So I don't want to maintain 100 designation. I will maintain only last. Before CAO, he was a VP, and then now CAO. Only this I can maintain. That is the slowly changing dimension of type 3. This will be used only in a hypothetical situations. You may not come across even a question or anything, just for you to remember. I'm telling. But SCD type 1, you don't maintain any history in a dimension table. This is applicable only to a dimension table, not a fact table. If SCD type 2, you are going to maintain the history of a particular column using start date, end date, and the current flag. And SCD type 3, you are going to maintain only the previous, latest, and the latest information. And it may change based on your project. It may change based on. Mhm. So these are the different types of dimensions that we are going to. This is the practical thing. Okay, I will be covering multiple times. I will be covering this during our course. Any questions? Anybody having in understanding SCD type 1 and SCD type 2? Hello.
Yeah, which SCD is column based? Uh,
SCD type 2 for the dimension table, it's all normally people will go for SCD type 1 only. Okay. But if there is a important information like HR related information, like employee related information, people will go for SCD type 2. Anybody facing any issues in joining the session? Any issues? You are excused to join or something. Whoever is already, like if you are new, I can understand, but whoever is old, anybody facing any issues is joining the session. Somebody complained. So this is about the data warehousing concepts that people use normally. Any questions you can ask. I'm done with my.
The interview questions are available in the AD folder, right? Those questions will be sufficient for the interviews.
It will be sufficient except the code snippets, because simple code snippets people are asking. But yes, those are sufficient if you want to face the interview, because all the notebooks is having the code snippets. So I would request you guys to practice those uh, code snippets. Like you need to have a hands-on also. They ask two, three questions basically in the SQL, uh, like what is the third highest salary? That's the for each department. First they will ask normally, and then they will ask for each department. So this is the most common question. So that is also there. There is an entry question notebook. So most of them are sufficient. I would
Okay.
say like you may come across one or two extra questions. I'm not denying that fact, but it should suffice to answer, let's say, 80% of the.
Mhm.
So there should be few others I have um, added. So I'll also add one more I received recently. A particular way that a company is doing that is related to core snippets. I will add that to the interview questions today. Actually, that should be. These are sufficient. If you,
Hello,
yeah,
please can you point to the folder containing the data warehouse concept?
tomorrow I will be covering like practical things like DDL, DML, DRL stuff. Actually,
Okay, I mean, can you point to the folder that contains the data
folder,
warehouse?
folder.
Yeah,
Yes, yes,
data warehouse.
yeah.
Sorry for my English. I'm calling from Canada. So,
No problem. Yeah, here we have this data warehousing concepts
okay,
information. Yeah,
okay.
and
So
if
the
you want to
audience,
practice,
okay,
please, please. If you
so
want
the
to
audience,
practice, there is a RDBMS score because I'm
okay, I
not
have,
covering RDBMS as such. Please try to practice by yourself. I am not covering by myself. I will be covering in the different similar stuff in the Delta Lake. So for you, if you want to practice, you can open this and try to do it in SQL online, SQL Lite online. It will be easy.
okay,
Yeah.
okay, thank you.
Okay, guys. If no more questions, I can wind up. From tomorrow, we'll be doing all this SQL stuff in the data, like in the database. Bye.
Okay. Sure.
Bye.
Thanks a lot.
Thanks.